Hello, in this tutorial we're going to look at the 3D texturing toolpath options available in Aspire and VCarve Pro. We're also going to cover how to create toolpaths for raised prismatic lettering that will leave the raised J and B logo in the middle of this sign. To explain how to use the 3D texturing toolpaths, we're going to use this very simple logo. This is a sign that's 18 inches by 18 inches and we're going to cut it into 1 inch thick material. If we click on the outermost circle, select that circle, you'll see down in the bottom right hand corner it tells us that it's 16.6 by 16.6 inches. This means it's 16.6 inch diameter circle. Okay, we're going to swap from the drawing tab on the left to the toolpath tab on the right. On the toolpath tab on the right we set up our material settings, so 1 inch thick material, and set up the clearance heights and the retract height for the home position. The first row of icons are for the two-dimensional toolpaths such as profiling, pocketing and drilling and quick engrave. The second row are our 2.5D/3D toolpaths, so 3D V-carving, fluting, 3D texturing, raised prismatic lettering and also our inlay toolpaths. In this case we're going to use the 3D random texturing toolpath. If I click to deselect everything so we've got no vectors selected, here we're going to use a 1/2 inch diameter bore nose. We're going to tell the software to carve the texture 80 thousandths deep into the wood. There's some sliders here for controlling the randomness of the repeatability of the texture pattern, so you can experiment with the sliders, experiment with different step overs and angles. Now if we calculate the toolpath, the three-dimensional view opens and you'll see that we've textured the complete panel. If we preview this toolpath, you'll see there that the tool is running across the material and texturing the whole 18 by 18 inch panel. If we just interrupt this for a moment by clicking on the little red cross, reset the preview. If we go back to the two-dimensional view, if we select a vector to texture, so we select the circle and we double click to edit the texture, select the circle. If we now recalculate that texturing toolpath, it's been limited inside the circle. If we say view, tile the two-dimensional view and three-dimensional vertically, we can now work in both the two-dimensional view open and the three-dimensional view. If we double click to edit this toolpath again, but holding the shift key down, we include the J and B logo in the selection, recalculate the toolpath. You'll see now that the toolpath misses out the letters, so if we say preview the toolpath, you'll see the 3D preview machining inside the circle but not texturing inside each of the letters in the logo. So the texturing can be constrained inside a selected vector. If we look at the texturing there in the three-dimensional view, you can see that it's moved around each of the J and the B and the ampersand in the middle. If we wish to engrave the texture into a pocket, so let's say for example we wish to pocket machine the background material away from the logo, we're going to say okay, reset the preview. We have the vectors selected, so I'm going to calculate a pocketing toolpath. Let's use a 1/4 inch end mill. So here we've got a 1/4 inch diameter end mill, step down a pass depth of 0.3 of an inch. Calculate. If we give this a depth of say 0.6 of an inch and we say calculate, we've now got two passes in our toolpath. Preview the toolpath, go 0.3 deep and then another 0.3 deep, so we're machining the background material away, leaving the J and the B raised. If we just add some colour to this, so preview in dark red, there you'll see that we've left the letters raised. If I place the cursor on the background here, down in the bottom right hand corner you'll see that it says Z equals 0.6 or Z minus 0.6. We can now texture inside that pocket area. So if we go back to the texturing tool, double click to edit, let's give this a start depth of 0.6 of an inch. And if we use exactly the same parameters, what you'll find is that the toolpath is going to carve into the lettering, and it will also carve into the outer edge of the circle. Let's just calculate it and show you the results. If we say preview this toolpath, so texturing is selected, let's double click to maximize this, preview the toolpath, you'll see that the texturing tool is running to the edge of the selected vector. What that means is that although the tip of the cutter stops at the vector, the radius is overcutting. So it's overcutting on the outer circle, but it's also overcutting on the letters in the middle. This isn't what we want. So when that's finished previewing, if we reset the preview, let's go back to the texturing toolpath, so double click to edit. There's an option on the form to create a temporary boundary. So this offsets the boundaries inwards to ensure that the selected area, that the toolpath only machines inside the selected area and doesn't damage the lettering or the outer boundary. So here we're using a 1/2 inch diameter cutter. We'd recommend that you offset this boundary inwards automatically by at least the radius of the cutter, so 1/4 inch. Now if we recalculate the toolpath, let's preview the pocketing toolpath. So preview, select the texturing toolpath, preview this toolpath. You'll see now that the toolpath is being limited. It's not machining right up to the selected boundary, it's machining 1/4 inch away from the boundary, at both the circle and around the lettering. Okay, let's give this toolpath some colour, so we'll make that the same colour, so dark red. So there you'll see that we've textured, but we've ensured by, let's just double click to edit this, by specifying a boundary offset of 1/4 inch, which is the radius of the bore nose cutter being used to form the texture. We've ensured that the letters don't get damaged and the outer circle don't get damaged. Let's make the actual logo a little bit more interesting. At the moment it's just a raised plane because we've pocket machined 0.6 inch deep. So if we close this toolpath, if we tile the views again, so view, tile vertically, this time if we just select the logo, the J and the B, so we click and drag to select. If we now go to use the raise prismatic toolpath option, let's select a cutter. So we're going to use, let's use a cutter from the tool database. Let's use a 1/2 inch 90-degree V-carving tool. If we click calculate the depth, you'll see there that it's telling us that to form a complete triangle or ridge at the highest point for each of these letters, we need to engrave or carve this at least 0.58 of an inch deep. We'll leave that as the default. The software automatically calculates that depth. We could force it to go deeper. We could say, okay, let's engrave it to the pocket depth of 0.6, but we'll leave it at 0.58 for the moment. If we calculate the toolpath, you'll see that the toolpath has been calculated to form the shape on the angled shape on the letters. So the prismatic toolpath selected, if we say preview this toolpath, and if we give that some color, so we'll make that, if we double click to maximize the 3-dimensional view, you'll see now that we've got this raised prismatic lettering that's been machined into the base of our pocket. And remember, the pocket was 0.6 inch deep. So just to summarize, we've taken the 2-dimensional data, so the vector boundaries, we've created a pocket between the inner circle and the logo, so this machines the background to a depth of 0.6 inch, so that pockets the background away. We've then calculated a texturing toolpath with the same vectors selected, but the key thing here is that we've specified a boundary offset allowance of 1/4 inch, which is equal to the radius of the 1/2 inch cutter that we're using to actually machine the texture. This stops the cutter from damaging or bashing into the boundaries that we wish to keep. Once we've done that, we then created the raised prismatic, if we close the texturing form, so the raised angled prismatic lettering, and we've done that using the prism machining toolpath. The software here has automatically calculated the depth for us. The software can do this by knowing the angle of the cutter that we use. So if we used a wider angle cutter, it would not need to be machining as deep. If it was a steeper angle cutter, it would need to be machining deeper. Thank you for listening to this tutorial.